Hello, this video is about new capabilities from large language models, specifically what can be done now with LLMs that couldn't have been done just a few years ago. My name is David Hood. I'm CEO of 42 Robots AI, where we help organizations implement AI effectively and practically within their organization. So most people, when they talk about LLMs and implementing them and what they can do, they basically are talking about chat and content generation, and this is the extent of what people are trying to use them for. But there's a whole lot more things that they can do, and that's what we're going to go over here. Now, this is not an exhaustive list. I'm sure there's some things that I'm missing, and if you have some ideas for things that are missing, please feel free to put them in the chat. Some things are kind of subcategories, and maybe some of these you could kind of merge a little bit or combine, and so there's a lot of really cool stuff that can be done with large language models. And so first of all, we're going to talk about semantic relevance comparison. So let's actually take this a step back and look at, we're able to take the text and essentially turn it into math that represents its meaning. And this is incredibly useful. It's core to how large language models work, but also this technology, this piece of technology enables new other cool things. Specifically, the main thing that enables are vector databases. This is a new type of database that enables new types of solution that's really cool. For example, it enables retrieval augmented generation, or at least the main way that retrieval augmented generation is built. By finding relevant text to what the user put in, you can insert into the context window the most relevant chunks of text from a vector database of, let's say, 10,000 documents or 10,000 chunks of documents. You can grab the top 5 most relevant ones and put them in the context window, and it can dramatically improve the output. Another thing that this enables is handling unexpected data. And I'm going to mention this a little bit more at least a few other places, because what you can do with a lot of like classic coding within software, you basically either had to really super narrow down the use cases, or you had to really do a lot of special case coding to get all the different possibilities for different types of inputs to try to compare things. And sometimes just the long tail just is huge and impractical to implement. Well, now with AI, you're actually able to do that. You can see, let's say there's 2 chunks of text that are about 5 or 6 words each, and they're worded slightly differently, so they're technically different, but essentially they mean the same thing. AI is going to be able to identify this and pick it up pretty quickly, and this really helps just immediately flatten out or solve that edge case. Now, summarized text, this does get talked about a little bit, although I mean this in a little bit of a different way. I mean this more as like text compression. This is very useful within software, but also within business processes. And also you can do this in a recursive way to where you're getting, let's say you have a very large document, you can recursively summarize it. So you have actually kind of maybe different layers of the summary. And maybe one human likes or one process or human likes the first layer of summarization and one likes the third. And so because they're useful in different ways. And this is actually incredibly useful within software in a lot of different ways. It's very useful. Additionally, I mean, this is definitely something that clearly could not be done like even just 2 or 3 years ago. There's no algorithm, that deterministic classic coding, non-random coding that summarizes text. There just doesn't exist. And so the ability to do this is very useful. You can also go the other way. You can expand text. So you could take like a chunk of this document and have it go the other way and make it more, give you more details about it. Not exactly content generation, although it's kind of, maybe content generation is a subset of this because it's taking what you gave it and it's generating content based upon that, what's relevant to what you gave it. It's not quite that simple, but it's similar. And maybe better way to think about this is elaborating on a section of content. But also you can use it to combine with other data. So let's say you're doing retrieval augmented generation, you take that chunk of text and you add some other text and it kind of merges it. Which brings me to one of the most surprisingly useful for real world solutions is data merging. This is incredibly useful. There's several use cases where there's no other way to do it. There's no other way to solve it without doing some sort of data merge. And this is where you can unify 2 overlapping data sets and avoid true duplicates. This is where you, again, back to the handle unexpected data, you have 2 sets of text that basically mean the same thing, but if you're just literally comparing them, they're not the same through classic coding, but through AI, they can go, oh, those mean exactly the same thing, so we're just going to merge them into one. Very, very, very useful. Data extraction. There's a lot of different stuff that you can use this for. A very simple use case is, imagine you put up a job post and you get 250 resumes that are submitted, and you want to make sure that that you don't want anybody who has less than 2 years of Python experience. All right. Well, you can have a little script that runs through all of them and says yes, no on that, and you can probably reduce the amount of applications by 75% just in a few seconds. And there's a lot more complicated use cases for this, where you're extracting key data points from potentially large amounts of documents. This saves a ton of time. And maybe it's a little bit of a subset of data analysis. Data analysis, just broadly speaking, there's so many different angles on this. I don't think anybody's really fully mined the value or the opportunity within data analysis for AI. This is directly related to my personal skill set. I have a lot of experience processing large amounts of complex data with code without AI. And so to me, this is just an amazing, amazing tool. One thing you can do is you can connect unconnected dots, or it's kind of highly dispersive data, which I guess that's kind of two ways of saying the same thing. This is something that where if you have a very long document and a human needs to find 4 data points in there and kind of make a conclusion based upon that, then you can do that. It's not quite data extraction, but it's, again, similar. And really the way I look at this is orders of magnitude more possibility in terms of our ability to process more data with AI than what we could do just a few years ago. That's 1,000x plus more data we can process, and there's lots of data out there as an organization or as a person with AI. And this is a major level up just by the quantity itself becomes a quality. Let me explain, for example, the difference between flying a plane and riding a bicycle. By flying a plane, there's just places you can go that you couldn't otherwise go. And it just creates different use cases and different opportunities that are not possible if you're just limited to a bicycle. And that's basically what we're looking at here. There's so many different ways to use AI to analyze data. It's hard to kind of put all of them in here. Maybe I'll make a separate video going into a little bit of some more details on some of the specific use cases. We also have path selection, so you can triage within a process. AI is very good at this. You can do very lightweight fine tunes. Let's say there's kind of 3 different paths. Again, this is a very good use case for handling unexpected or kind of unstructured or a variety of different types of data sets. You can set up a very good triage very quickly if you're trying to have a process select a path. And along the same lines, but not quite the same thing, is categorization. Again, being able to handle unexpected data, this is very useful. This is kind of the oldest of some of the kind of most recent last decade plus of AI models, which is that it's very good at kind of is it a cat or a dolphin, right? Or is this text is the customer's response positive or negative? These are very, very good use cases for LLMs. Again, you could do a pretty lightweight fine tune because it is naturally very good at this. And kind of, if you haven't heard about this before, this might seem odd, but actually it's really good at checking itself. So it could even be the same large language model. It does a thing and you want it to go, well, did you do it right? And sometimes it'll actually look at it and go, actually, I messed up here and here. And maybe you can use 2 different models to do that, or maybe 1, or maybe there's multiples. Maybe you run 2 different models for a specific process, and then you have another model that evaluates the outputs. There's a whole bunch of different cool stuff you can do with kind of like post-checking with LLM checking. So if you are interested in implementing AI at your organization, call or click the link below to get a free custom AI implementation roadmap. My name is David Hood at 42 Robots. Thanks for watching. Have a great day. Bye.